In this video, I will be showing you how to simplify expressions involving inverse trig functions, such as these, nested inside of other trig functions. And we will do all of these without a calculator. Now, there are two things I'm going to assume that you know as I proceed. Thing number one, the range of inverse trig functions are restricted. The ranges are restricted. Inverse sine can only have answers on the right-hand side of the unit circle, from negative pi over 2 to positive pi over 2. Inverse cosine, the range is restricted to the top half of the unit circle, from 0 to pi. And inverse tangent, or arctangent, is only allowed to have answers between negative pi over 2 and positive pi over 2, and the endpoints themselves would be undefined. For example, at this point, the tangent would be 1 over 0, and that would be undefined. So keep the range restrictions for inverse trig functions in mind. Also, by now, you should have memorized these special values. So I'm going to assume that you have each one of these 9 facts memorized as we go along. Okay, now the first 6 problems I'm going to do involve the trig function and the inverse trig function one inside of another. We've got sine and inverse sine and sine, cosine and inverse cosine. Okay, now in all of these cases I'm about to show you, the function and the inverse function cancel each other out, and you're just going to have the number inside. Now that doesn't work 100% of the time, so I need to sort of explain to you when it's going to definitely work and you don't really have to think about it. Now first of all, remember what an inverse trig function is. An inverse trig function is just an angle. This inside of here is an angle. It's the angle whose sine is 3/4. Now 3/4 is not one of the values that we have memorized. So there's no way we can actually find out what this angle is without a calculator. But we don't need to. We could draw a picture of this if we wanted to. Okay, we could draw the angle whose sine is 3/4 if we remember that sine is opposite over hypotenuse. So that's like y over h. And so sine is only defined, inverse sine is only allowed to be in the first and fourth quadrants. So that means it's going to either be here or here. Since this is positive, that puts it in the first quadrant. So if I were to draw this angle, I would draw it right here. I have y over h. Okay, so the y value would be 3. And the hypotenuse would be 4, all right? Sine is opposite over hypotenuse. And so I have this picture so far. I don't know what this angle is, but this is a picture of the angle whose sine is 3/4. Now, then we would evaluate the outer function, which is saying, okay, now what's the sine of that angle? What's the sine of this angle? Well, of course, because of the way we set it up, the sine of this angle, theta, that I've just drawn, is 3/4. So the answer would be 3/4. Okay, so then you look back and see, okay, did I need a triangle? No, I did not need a triangle. I'm seeing the sine and the inverse sine are just undoing each other. So, of course, the answer is 3/4. So the thing that sometimes messes us up is restrictions on the range. But here's the thing. So there are 2 main rules, sort of shortcuts I want to tell you. If the inverse trig function is on the inside, then you don't have to worry about the restrictions because the one on the inside automatically has to fit the restrictions. So then the one on the outside doesn't have any restrictions, so you're fine. It's already taken care of by the inverse trig function already being restricted to just the first two, the two quadrants on the right. So the bottom line is you can go ahead and let these cancel each other out anytime you see that the inverse trig function is on the inside. All right, so I'm just going to make a little note to you. Inverse on the inside. Okay, go ahead and cancel these out. All right, you don't have to worry about it. That'll work 100% of the time. So I just get 3/4. Now, number 30 represents a different case. I don't have the inverse trig function on the inside. It's on the outside. So now I do have to worry about the restrictions. But as long as the inner function does not go outside of the restriction, then we're still okay. So I can still cancel these out. So if the, I'm seeing pi over 2. Pi over 2 is in the first quadrant, so it is certainly within the restriction. So I can go ahead and cancel these out. Inside the restriction, so you can go ahead and cancel these out. So the answer to this one will just be pi over 2. So these are the two main rules that I want to give you. If the inverse trig function is on the inside, you don't have to worry about the restrictions. You can just go ahead and cancel these out. If the inverse trig function's on the outside, just make sure that the angle on the inside is inside the restricted range. Then you can go ahead and cancel these out. Okay, so looking at number 31, see how the inverse trig function is on the inside? Then you can go ahead and cancel these out. These are going to undo each other. The answer is going to be 2/9. You don't have to draw any pictures or anything like that. Okay, look at number 32. The inverse trig function is on the outside, so I have to think about it. Is pi within the restricted range? Well, for cosine, the restricted range is the top half of the unit circle, from 0 to pi, including pi. So, since pi is in the restricted range, all right, pi is okay, then these are going to go ahead and cancel each other out. So the answer is going to just be pi. Okay, look at this one. Oh, look, the inverse trig function is on the inside. I don't need to worry about the restricted values. These are going to cancel each other out. And I'm going to get pi over 4. Okay, this one, the inverse trig function is on the outside. So I just need to worry, is this okay? Is this within the restricted range? Well, pi over 3 is in the first quadrant. And the first quadrant is within everybody's restrictions. So this is definitely okay. So I can just go ahead and cancel these out. So I am going to get pi over 3. So keep that in mind and you'll be okay. If the inverse trig function is on the inside, these opposites are going to, these inverse trig functions will cancel each other out. If the inverse trig function is on the outside, just make sure that this angle is in the restricted range. Okay, now for the rest of these, now I'm beginning to deal with angles that are not, I'm beginning to deal with trig functions that are not direct inverses of one another. So I have cosine and tangent. So I have to think a little bit more. So as I do the rest of these, I'm going to evaluate the inner function and then consider the outer function. So what is the inverse tangent of 1? Inverse tangent is just an angle. It's the angle whose tangent is 1. So what angle has a tangent of 1? Well, this is one of our memorized values. Pi over 4 has a tangent of 1. Okay, so that means this is pi over 4 on the inside. So now I have the cosine of pi over 4. Well, that's something else I've memorized. That is 1 over radical 2, or radical 2 over 2. That's it. All right. Now, number 36. The cosine of pi over 2. We have memorized that. All right, the cosine of pi over 2. Well, we haven't exactly memorized that. Pi over 2 is the same thing as 90 degrees. Okay, so this the coordinates of this point are 0, 1. Cosine is the x value on the unit circle. So that means the cosine of pi over 2 is 0. So that means I'm really asking you for the inverse sine of 0. Now, the inverse sine is just an angle. It's the angle whose sine is 0. So what angle has a sine of 0? Well, on the unit circle, the y-coordinate is the sine. So where is the y-coordinate 0? The y-coordinate is 0 here and here on the x-axis. So both of these points will have a sine of 0. But only one of these is within the restricted range for the inverse sine function. Got to be on the right-hand side. Okay, so I'm going to ignore that one. This is a no. This is the 1. So that is 0, angle 0. Boom. So that's why the answer to this is going to be 0. Okay, and as opposed to pi, which is not within the restricted range. Okay, there's this extra 2 in here, but I don't really have to worry about that right now. Right now, I'm just going to evaluate the inverse cosine of radical 2 over 2. Of course, radical 2 over 2 is the same thing as 1 over radical 2. Inverse cosine is just an angle. It's the angle whose cosine is 1 over radical 2. This is something that we have memorized. The cosine of pi over 4 is radical 2 over 2. So this is pi over 4. Okay? So that means what we have is 2 times pi over 4 on the inside of here. Now, so that is the sine of 2 pi over 4, and this reduces down to pi over 2. So what's the sine of pi over 2? Well, looking at the unit circle, pi over 2 is right here. This is the point 0, 1, and the sine is the y value. So the answer of this is 1. Okay, number 38. The inverse tangent of 1 is the angle whose tangent is 1. So the tangent of pi over 4 is 1. That's one of the values that we memorized. Tangent of pi over 4 is 1. So this is pi over 4. Okay, minus. Inverse sine is the angle whose sine is 1. What angle has a sine of 1? On the unit circle, sine is the y value. This is the angle that has a y value of 1, because this is 0, 1. The y value is the sine function. So this is pi over 2. So that means this is going to be pi over 2. Okay, so I'm being asked to find the sine of this minus this. Okay, thinking about our like denominators, right, if I multiply these both by 2, then I'm looking at pi over 4 minus 2 pi over 4. That's going to be negative 1 pi over 4, or negative pi over 4. So we're talking about the sine of negative pi over 4. So what's that? Well, ignoring the negative sign for a moment, we've memorized that the sine of pi over 4 is 1 over radical 2, or radical 2 over 2. So what about this negative sign? Is that going to make this negative? Well, think about it for a second. Okay, so here's pi over 4 right here. All right, the sine of pi over 4 was 1 over radical 2. Now here is negative pi over 4 down here. Okay, will this be positive or negative? Well, remember that the sine is a y value on the unit circle, and y values are negative down here below the x-axis. So that means these should be negative. Okay, so that's going to be the answer. Negative 1 over radical 2, or negative radical 2 over 2. All right, number 39. Inverse tangent of 1. That's the angle whose tangent is 1. We know that that is pi over 4. Right? The tangent of pi over 4 is 1. And then we have minus inverse sine of 1. The angle whose sine is 1 is pi over 2. All right, like we discussed on the previous problem. I guess it was this problem right here. This is pi over 2, 0, 1. The 1 is the sine value. Okay, so the angle whose sine is 1 is pi over 2. All right, so now we have the cosine of all this. Now we just did this on the last problem. We had pi over 4 minus pi over 2. That was the same thing as pi over 4 minus 2 pi over 4. And that gave us negative pi over 4. So the same thing is going to happen here. This is going to be the cosine of negative pi over 4. So we have memorized, ignoring the negative sign for a minute, we've memorized that the cosine of pi over 4 is 1 over radical 2, which is the same thing as radical 2 over 2. What about negative pi over 4? All right, let's look back at that same picture. This is pi over 4 right here. All right, that's positive 1 over radical 2. What about this? This is negative pi over 4 right here. Will the cosine be negative or positive in this quadrant? Well, cosine is the x value on the unit circle, and x values are positive on the right-hand side. So both of these will be positive. Okay, so this is going to be the answer. No need for a negative sign. So 1 over radical 2, or radical 2 over 2, positive. All right, last one. Inverse cosine of 0. This is the angle whose cosine is 0. So what angle has a cosine of 0, you say? Well, cosine is the x value on the unit circle. So what angle has an x value of 0? Well, that would be here and here, all right? On the y-axis, the x value is 0. But for inverse cosine, you have to stay on the top half of the unit circle. So that means this one down here is definitely a no. All right, so I'm talking about pi over 2 then. So this is pi over 2. Inverse sine of 1/2. That's the angle whose sine is 1/2. We have learned that the sine of pi over 6 is 1/2. So this must be pi over 6. And we're supposed to be adding these. So now the problem becomes, what's the cosine of pi over 2 plus pi over 6? Of course, we need like denominators, so I would multiply these by 3. So then the problem becomes the cosine of 3 pi over 6 plus pi over 6. So that means we're looking for the cosine of 4 pi over 6. Which means we're looking for the cosine of 2 pi over 3. So what's the cosine of 2 pi over 3? Well, the reference angle is clearly pi over 3. And we know that the cosine of pi over 3 is 1/2. So what about 2 pi over 3? Well, 2 pi over 3, okay, so this is like 1 pi over 3, 2 pi over 3 would be right here. Since cosine is the x value on the unit circle, we understand that x values are negative on the left side, to the left of the y-axis. So cosine should be negative over here, so this should be negative 1/2. So that's why the answer here is going to be negative 1/2. All right, that's the end of this video. I hope it was helpful, and I will see you on the next video.